Hi guys, this is the lesson recap for Thursday, March 19th. Just a reminder about the due date. It is the 23rd, which is Monday. And today we talked about chosen design and detailed design. And I'm just going to revisit design ideas because it has a better example of a flowchart. So let's just take a look at that first. So back here in design ideas, you were asked to create a flowchart, and we originally gave you, am I already editing this thing? I think I am. Let's get out of there. All right, we gave you this short video of flowcharts, but now we've added an example down here, and this is what the year 7s are doing, so should be easy enough to follow. And note it's using all three of the main flowchart diagrams, or not diagrams, but symbols that are mentioned in this video back here, namely the start and stop circle, oval, the square process symbol, and the diamond for making decisions. So in this case, the Scratch game, it's a year 7 thing, has a home screen with some buttons on it, and they check to see if the play button was pressed, and if it was, it goes to this change level screen. And from there, it can take different paths out. Now, if the instruction button was pressed, it comes over here, shows the instructions. If they press play, then they continue over to here. Now, normally with a decision diamond, you would have one arrow in and two arrows out. One for yes, the answer to the question is yes, and a no for the answer is no. And in this case, the no would go back to this box, this process box. All right, so there are two paths into this screen, either directly through play or indirectly through the instructions. And once you're here, you can, there are, well, 4 ways out. One is via the quit down to here for goodbye and the program. And the other is via the level buttons. And each of these takes you out to a level, whatever happens in level 3. Now, level 1 is probably more than just a simple box. Again, this is year 7. Yeah, I mean, they spent more time on the decision boxes than what's happening in here. I think you get the general idea. You would probably have perhaps a bit more to say about what might happen in here. This is a fairly big process area, and probably in the case of a game, these three are, what happens in here is largely the same, except maybe a higher degree of difficulty, but what goes on is basically the same. So anyway, you go through these levels, and when you're complete with a level, you come out and it asks, do you want to try a different level? If you do, you go back to the level screen. Otherwise, you exit and end the program. So that's a basic flowchart. Now, let's go back to the lessons page. Now, for chosen design, this is very straightforward, and we tried to scale this back as much as we can and still comply with some of the requirements of the MYP design cycle. So here you're going to check the features of your design spec to ensure, and you're checking to see that your design has addressed those features. So you can take the features from your spec. Sorry, I'm in design spec. I should be over here in chosen design. Here you are going to, the objective is to ensure that your design ideas have addressed all the features listed in the design spec. And you can use this table to do that. You can copy paste your design specification into this column here. Now, I have a little bit of a problem with the timing of this. Your design is not just the flowchart up here, it's also the design of your code, the design of the software. The flowchart has to do with the flow through the program. The pseudocode which you're producing down here has to do with the logic of the code. And the two combined really form the design. And it's against that design which, well, it's that combined design which has to be checked against the specification. Why is it in this order? Well, because we do things a little differently in computer science than we do in product design. And, you know, the layout of this stage of the design cycle, in my humble opinion, suits the product design life cycle a little better than it suits the software development design life cycle. So anyway, keep that in mind. I would first do this detailed design and then come back and do this and check to see that your flowchart and your pseudocode have addressed all the features in your spec. So just copy paste your specification list of features from here into this table, into the second column, and then address, perhaps with evidence, whether or not your design has addressed those features. Very straightforward. Now, down here in detail design, now you're designing the code. You're not writing any code, but the idea is to have something from which you can write the code. So source code comes last. First, we state the problem. Then we try to express the logic of the solution in English. The algorithm is the logical steps needed to solve the problem. And we first expressed it in English. Then we take one step closer to the source code by expressing that same logic in pseudocode. Pseudocode is a language-neutral notation that the software architect or designer creates and then gives to the software developer. And the developer would then implement that logic in some target language. So as you're composing pseudocode, you may not even know what the target language is. And if you do know, you should probably just forget about it. You don't want the pseudocode to look like source code. So the detailed design should be clear enough so that someone could look at your flowchart or storyboard, we gave you that option up above, and read your pseudocode and be able to write the source code. So now, I've taken this example from exercise 6. Now, if you recall, let's just take a quick peek back at exercise 6, which is over here. Exercise 6 and 7 both contained the pseudocode from us so to help you write the code. And we mentioned back then when we were talking about these exercises that we gave this to you because it would be helpful later in the design stage. And here it is. So that was the pseudocode for exercise 6. And for exercise 7, here is the pseudocode again. Now it's very similar to what was in 6. Now I've taken the pseudocode from 6, just to keep it simple, and used it here in the handout. So here is the algorithm expressed in English. This should look if you've done exercise 6, this should look very familiar. Let's take this line out. And if you haven't, well, just read, you can refer back to exercise 6, or you can simply read this explanation of the problem. So it's prompting the user for a number. The number corresponds to the shape the program will display, or 0 to exit the program, and you loop until the user enters a 0. Now, if they attempt to quit, you need to get confirmation from them before you do quit, and if you get the confirmation, then you end the program. Now, I think this is incomplete because down here the pseudocode is expressing how many times each shape was displayed, and that's not mentioned as a requirement up here. So if the user enters a value other than 0, 1, then display. So where does it say? If the user enters 0, say goodbye, and here it should say goodbye, display the number of times each shape was displayed, and exit the program. All right. I'm just going to open this up a little bit, just make it easier to read, like so. All right. So now down here, now note there's no source code at all here. When you did exercise 6 and 7, the pseudocode was sort of embedded as comments into the skeletal source code file, source file. Here is just pseudocode, and that's what you should do, is just pseudocode. So again, it sort of looks like a program, but it reads like C. It reads like English. Now, it reads like English because you don't have to worry about semicolons. You don't have to describe the variable type over here. Just indicate that it's a variable. We don't really know if it's a while loop or a for loop. The programmer will decide. The programmer is the expert with the details. You're the expert with the logic. So here you're just going to keep looping until you get a 0 from the user. And then you prompt the user, get the shape number from the user, and then you check what number they gave you and display the corresponding shape. And you track how many times you displayed each shape. And then finally, if you get the 0, now this looks like the indentation's off. If you get the 0, whoops, I can't do that. I'm editing this on the fly. I'm just going to type. If you get the 0, then you should prompt the user. This is where you prompt, "Are you sure you want to quit?" And what else? Prompt the user if the 0. Okay, this is a little confusing, isn't it? This is why indentation is important. Now, if you did get a 0, you should display the goodbye message. I'm going to stick this. Well, okay, yeah, you display the goodbye message here, and then you can display, well, let's see, why is that down there? It's probably not that important whether it's here or here. Yeah, I mean, you could even just say this. Let's just do this. Let's just move this over here. So you're going to end this loop, and at this point you're going to say, whoops, sorry. At this point you're going to say goodbye. In fact, you should say goodbye after you display. Okay, sorry guys, I did not. I guess I didn't read this carefully before I started the screencast. All right, so now here I'm going to say if the answer is 0, then you're going to exit the loop. Again, I'm not worried about the programming syntax or source code syntax. We just need logic. The programmer can figure this out. All right. Now, all right. Okay, so I think that's it for detailed design, and yes, that's it. All right, I'm going to end it there, guys. If there are any questions, just put something on the chat or send me an email. I prefer you put it on the chat, though. All right, cheerio.